We are now on modifying virtual machines. In modifying virtual hardware, here is an example. The example is when we created a virtual machine last year, we assigned it 1 CPU, 4 gig of RAM, and 40 gig of virtual hard disk space, and at the time that was sufficient. But since then, we have experienced significant use, and when we look at the performance of the operating system in that virtual machine, we see that CPU utilization is through the ceiling. We are using up all of our RAM, and the hard disk is almost full. So what we can do is we can increase the virtual hardware. We can increase the number of CPUs, the amount of RAM, the hard disk space, or we can even add hard disks. To modify the virtual hardware, we go to the virtual machine, in this example, server 2012, and I right-click and I select Edit Settings, and then we see an error message that says you have restricted editing capabilities. Some devices may not appear in the list. Some devices may appear as restricted. If you want to edit the advanced features of this virtual machine, please use the vSphere web client. We are not going to edit the advanced features right now, so we do not need the vSphere web client right now. We will look at it later. So we click on OK. Now I can see that this virtual machine has been allocated 4 gig of RAM. To increase that to 8 gig, I just take the little slider bar next to memory and I click on 8 gig, and now I have allocated it 8 gig of RAM. Under CPUs, it was originally allocated 1 CPU, and I will add a second CPU to that virtual machine. The hard disk, 40 gig, is not sufficient, so I will change that and increase that to 80 gig. So that increases hard disk space, CPU, and RAM. And just another variable that we can configure while we are here is the DVD drive, and currently the DVD drive points to the physical DVD drive in the ESXi host. But if we want to, we can configure the DVD drive of the virtual machine to point to an ISO on a data store, and we frequently do that when we are installing operating systems. Another variable to discuss is the virtual adapter. If you recall, in an earlier chapter we talked about moving a virtual machine from one virtual switch to the other, and that is where we would configure the virtual adapter network, and the default is VM network, but I could change it to another network. And then we have an Add button across the top of the screen, and if we click on the Add button, it allows us to add additional virtual hardware. For example, I can add a second Ethernet adapter if I want to implement network interface card teaming on this specific virtual machine. Or under hard disk, I can add an additional hard disk to this virtual machine to increase its capacity. So we have increased the RAM, CPU, and hard disk space of this virtual machine. So if server utilization has drastically increased, then we can increase the amount of virtual hardware. Another disk option is called raw device mapping, and you may have noticed that when we created a new virtual hard disk, we could select create new virtual hard disk, use an existing virtual hard disk, or another option is raw device mappings. And the description shows that we can give your virtual machine direct access to the storage area network. This option allows you to use existing storage area network commands to manage the storage. So what raw device mapping does is it gives the guest operating system direct access to the disk array. It bypasses the virtual hard disk encapsulation process. Typically, you don't do it. The default is to use virtual hard disks and VMFS data stores, but you would only do it for applications that specifically require direct access to the LUN, such as Microsoft Cluster Services or Microsoft failover servers. But typically, you don't use raw device mapping. Inflating a thin provisioned disk. We've talked about what it means to thin provision a virtual hard disk. When we were creating a new virtual machine, we saw an option under disk provisioning to thin provision or thick provision. If you thick provision and you assign 40 gig to the virtual machine and it's thick provision, it will take up 40 gig on the disk array. But if you select thin provision, it doesn't really take up any space on the data store until you have actually saved data to the virtual hard disk. We thin provision. It's a good way to save hard disk space in the short term. So you can inflate a thin provisioned disk, and when you inflate a thin provisioned disk, then what it does is it really takes the space on the disk array. And the reason you would do that is so some other virtual machine does not take the space on the disk array. To inflate a thin provisioned disk, you right click on the virtual machine's VMDK file, virtual machine disk file, and select inflate. So let's do it. I go to the virtual machine and I go to the data store and I right click and select browse data store. Then I select a VMDK file that I want to inflate, and you can see it's currently thin provisioned. It's been configured as 41 gig, but it's only using up 7 gig of space, so that's how I know it's thin provisioned. So if I right click on it and select inflate, then it thick provisions it and causes it to take up all of the full 40 gig on the disk array. And the reason we do that is so this virtual machine will be guaranteed to have that space available to it. Virtual machine options. If we go to a virtual machine and right click and select edit settings, we already did the hardware tab. Let's look at the options tab. Let's just look at some of these options here. General option is the virtual machine name. You could change the virtual machine name, but you usually don't. And then the operating system which is installed, Windows or Linux, and then the edition of Windows that is installed. And under VMware Tools, it shows which buttons control which options, which actions on VMware Tools, such as shut down the client or suspend. We typically we would enable the running of VM Tools scripts after power on, after resuming, before suspending, and before shutting down the guest. And under advanced, we typically click on check and upgrade VM Tools during the power cycle. And then the last one, which we almost always want to select, is to synchronize this virtual machine with the ESXi host, which, as you know, is synchronized with an internet time server. Under boot options, you can see that typically the virtual boot firmware is going to be the BIOS, basic input output system. If you were using a particularly new operating system that expected EFI, the expected firmware interface. That's just an advanced form of BIOS. You have the option to select that, but most operating systems are not using it. Power on boot delay is set to 300 milliseconds. So what we got is we got 3 seconds to press the F2 button if we want to run the BIOS setup for the virtual machine. You know, if you want to run the BIOS setup for a computer, when it powers on, you have to make sure to press the F2 button, or sometimes it's the F10 button, to go into the BIOS. And sometimes it's tricky to hit it in just that short 3-second period. Another thing you can do, which is very convenient, is you select the Force BIOS Setup option. And when you select that, the next time the virtual machine boots, it will force entry into the BIOS Setup screen. And under failed boot recovery, if the machine cannot boot to the data store, what do you want it to do? And in this example, it'll try to reboot continuously after 10 seconds. And the idea is it's just taking a while for the data store to become available. If we select the tab across the top that says Resources, that talks about resource allocation, configuring shares, reservations, and limits on memory and CPU. We will not discuss that now, but we will discuss it later on in the course. Now let's modify virtual machines using the vSphere web client. Now we've been using the vSphere desktop client, and the vSphere web client is similar to the vSphere desktop client, but it's got a web interface, and one difference in it is that it's much newer and it gives you access to some new advanced features. So if we go back to the vSphere desktop client and we go to a virtual machine and right click on it and select edit settings, we have an error message that says you have restricted editing capabilities on a virtual machine version of 9 or higher. Some devices may not appear, some devices may appear as restricted. Okay, here's what we want. If you want to edit the advanced hardware features of this virtual machine, then use the vSphere web client. So let's go to the vSphere web client. Let's use the vSphere web client to see how we can modify virtual hardware. And on one hand, we're going to see it's very similar to the vSphere desktop client. So let's do it. I go into an Explorer, an Internet Explorer such as Google Chrome, and then I type the administrator name and password, and I log in to my vCenter server, and now I'm connected to my vCenter server using the vSphere web client. I go to hosts and clusters, and here's a virtual machine where I want to increase the virtual hardware. So I right click on that virtual machine, select edit settings, and just like in the vSphere desktop client, I can assign more CPUs if I want to. Memory is currently 4 gig. If I want to push memory up to 32 gig, I can assign 32 gig to the virtual machine. Under the hard disk, if I want to increase the size of the hard disk to 120, I can certainly do that. And under the network adapter, if I want to move this virtual machine to a different virtual network, I do it by modifying the virtual adapter. I can also add new hard disks. I can add new devices, add new virtual hard disks, add additional network adapters. Same stuff we were doing with the vSphere desktop client. The vSphere web client is similar to the vSphere desktop client, but what it does that the vSphere desktop client can't do is it allows us to configure certain advanced variables which are not available in the vSphere desktop client, particularly the ability to edit virtual hardware version 11. Virtual hardware version 11 has additional capabilities. It supports 128 virtual CPUs per virtual machine, and in previous editions the highest number it could get was 64. It supports 2 terabytes of RAM per virtual machine. In previous virtual hardware editions it could only support 1 terabyte of RAM. And virtual hardware version 11 supports something called vFlash, which is a disk caching mechanism to improve the speed of the disk I/O. So let's take a look at some of these advanced features. I go into the vSphere web client and I will right click on my virtual machine, and under edit settings, yes, we can change CPU and memory and hard disk, but let's expand hard disk, and here is a new feature not available through the vSphere desktop client that says virtual flash read cache. I click on advanced and I can enable the virtual flash read cache. The virtual flash read cache is a disk caching mechanism that uses flash drive technology to speed up disk I/O. This option is only accessible in the vSphere web client. Modifying virtual machines summary. You can modify virtual hardware, increase the number of CPUs, increase the RAM, increase the size of hard disks or add additional hard disks, change the virtual network that the network interface card is attached to, or add additional network interface cards for NIC teaming, or modify other variables such as where the DVD points or startup options. And then the vSphere web client allows us to enable features that are only available in virtual hardware version 11. And this concludes our video on modifying virtual machines.